So in problem 7.3, we're asked to use equation 7.13 given in the textbook to obtain the following expression for the determinant. So that expression there. So very obviously, we just start out with equation 7.13, and that gives us a equivalent expression for the triple dot product of the tensor f. So now that we have that, we can solve for the trace of that triple dot product. So we simply take the trace of each individual tensor f term in the 7.13 equation. So all we're doing is taking the trace of the dot product between f and f, the trace of f, and then the trace of the identity matrix. So equation 7.9 tells us that the trace of the tensor f is just equal to I1. So following that reasoning, I concluded that the trace of the dot product of f and f should just be I1 times I1. So we get I1 squared that replaces that. And again, trace of f is just equal to I1, so we replace that here. And then the determinant of the tensor f is equal to I3. We're given that in the textbook as well. So we replace that. And then the trace of an identity matrix is just 1 plus 1 plus 1, because an identity matrix is just a diagonal of ones, and the rest of the spaces in the matrix are 0, so that one's pretty easy. That ends up just being 3, so we end up with this slightly more simplified expression here. If we rearrange that, then we can solve for the determinant f in terms of I1, I2, and the trace of that triple product f, or triple dot product f, rather. So after doing all that, we end up with the equation that we wanted to prove.